So students, today in this video, see derivative of an implicit functions. What is implicit function? See the definition. An equation of the form f of xy equal to 0, in which it is not possible to express y directly in terms of x, is called an implicit function. So function f of xy equal to 0. For example, this is a function x plus sine of xy minus y. So x and y are used here. So this is the function in x and y and equal to 0. Now this function we easily cannot be written in terms of y equal to. So this type of function, this is called implicit function, otherwise it is explicit function. Okay, so how to find the derivative of implicit functions? See, rule to find dy by dx for implicit functions. Number 1, differentiate both sides of given relation with respect to x regarding y as function of x. So आपको क्या करना है, इस फंक्शन को, इस रिलेशन को डायरेक्टली वहीं पर डिफरेंशिएट करना है. यहाँ पर एक बात ख्याल रखना है कि जहाँ पर y है वहाँ पर y को भी डिफरेंशिएट करना पड़ेगा dy by dx. Okay, then find the value of dy by dx. Okay, take an example. Find dy by dx in the following. Number 1, ax plus by square equal to cos y. Okay, so we can directly differentiate here. The solution, differentiating with respect to x. So student, derivative of ax is a plus b is constant number, and you know that derivative of y square is 2y, but since it is a term in y, so write dy by dx, differentiate this y also with respect to x, then equal to cos y का डेरिवेटिव क्या होगा माइनस sin y, लेकिन y का टर्म है, so dy by dx. Now grouping dy by dx terms, so b, I am writing this 2by dy by dx, then this plus sin y dy by dx equal to this minus a. Therefore dy by dx in bracket twice b, this twice b and y also, twice by plus sin y equal to minus a. Therefore dy by dx equal to minus a upon twice by plus sin y. So student, this is the derivative of this ax plus by square equal to cos y. Okay student, so next take another example. Suppose take xy, ax into y plus y square equal to tan x plus y. Okay, now differentiating this with respect to x, differentiating with respect to x. So x into y product is there, so we have to use product rule. First function into derivative of y is dy by dx plus second function into derivative of x is 1, so write 1 plus twice y square, derivative of y square is 2y, but since it is the term of y, so write dy by dx equal to derivative of tan x is sec square x plus derivative of y is dy by dx. Okay, now grouping dy by dx term. See here, this is x into dy by dx plus y plus twice y dy by dx, then equals to sec square x plus dy by dx. So grouping dy by dx term, so we get here this is x, this term is there plus 2y, dy by dx minus dy by dx, it will be minus 1 into dy by dx. To the right hand side we get here sec square x and this minus y. Okay, therefore dy by dx equal to sec square x minus y upon 1 plus 2y, 1 plus this is x plus 2y, x plus 2y and minus 1. So this is the derivative of this x into y plus y square equal to tan x plus y. In this way, student, we can find the derivative. Students, now take another example. Take another example, that is x square. Find dy by dx. Find dy by dx in the following. Okay, so this is question number 5 in exercise 5.3. X square plus x into y plus y square equal to 100. So solution. So x square differentiating with respect to x. So x square का डेरिवेटिव क्या होगा 2x plus again here the product is x into y. Product rule, first function into derivative of y is 1 and since it is the term of y, so dy by dx plus second term y into derivative 1 x is 1 equal to twice y, derivative y square into dy by dx, it is plus dy by dx equal to derivative of 100 is 0. Therefore 2x plus x into dy by dx plus y plus 2y into dy by dx equal to 0. Now grouping this dy by dx terms, so x plus 2y into dy by dx now equals to, this is minus of this 2x becomes minus 2x and this y becomes minus, so this is plus y, this is minus y. Okay, minus into this plus y, it becomes minus y to the right hand side. Therefore dy by dx equal to, this is minus in bracket 2x plus y upon x plus 2y, 2x plus y upon x plus 2y. Okay student, so in this way we can find derivative. Take another example, that is 6. Suppose x cube plus x square, x cube plus x square y plus xy square plus y cube equals to 81. Okay, now directly we can differentiate. This is also implicit function, directly we cannot write in terms of y equals to. So differentiating with respect to x. So x cube का डेरिवेटिव क्या होगा 3x square plus here is the product. So first function as it is into derivative of y is 1 and since it is the term of y, so write dy by dx, then plus second term y into derivative of x square is 2x. Complete the bracket. Again here is the product x into y square. So first function as it is into derivative of y square is 2y, since it is the term of y, so into dy by dx plus y square into 1 plus y cube का derivative 3y square, it is the term of y, so 3y square into dy by dx derivative of 81 is 0. Okay, so this implies 3x square plus x square dy by dx plus twice xy, this is twice xy, then plus twice xy dy by dx, this plus y square, okay, plus 3y square into dy by dx, this is equals to 0. Now grouping dy by dx terms, so x square plus 2xy, this 2xy, and then plus 3y square into dy by dx, and to the right hand side we get this minus 3x square, then this minus 2xy, and this is minus y square. Therefore dy by dx equals to, I can take minus as common, 3x square plus 2xy plus y square whole divided by x square plus 2xy plus 3y square. So this is the derivative. So it's going to, in this way we can differentiate the given implicit function and we can find out the derivative of the given. Okay students, now take one more example. Find dy by dx. Question number 7. Sin square y plus cos x into y equals to pi. Pi is a constant number. Okay, so solution: differentiating both sides with respect to x. So students, sin square y, it is sin y whole square in this way. So x square 2x like that. So twice sin y, then sin y is also a function into derivative of sin y is cos y, and it is the term of, in terms of y, therefore into dy by dx. See, derivative of x square is 2x, like that. It is sin square y means sin y whole square, so twice sin y into derivative by using chain rule, into derivative of sin y is cos y, but there is term of y into dy by dx plus. Now here it is the product x into y, cos of x into y. So whatever it may be the domain of the function, cos का derivative क्या होगा, minus, so that will be minus sin x into y into ये जो product है उसका derivative into derivative of x into y, derivative of pi is 0, so twice sin y cos y minus sin xy, sin minus sin xy, derivative of x into y, first function x into derivative of y is 1, and since it is the term of y, dy by dx plus second term y into derivative of x is 1 equal to 0. Twice sin y cos y minus, so I am writing this, take the multiplication, minus x into sin xy into dy by dx, then this will be minus y equal to 0. Grouping, there is only one term. Oh, here it is dy by dx, sorry, dy by dx, so here it is also dy by dx, this one. So this is twice sin y cos y dy by dx, then this is minus x sin x into y dy by dx equals to y, is minus y to the right hand side. So taking dy by dx common, we get twice sin y cos y minus x into sin x into y. equals to y, right? Therefore twice sin x to y divided by dx. Okay, therefore we get twice sin y, sorry, dy by dx. Therefore dy by dx, is any term left over here? Sorry, this will be, sorry, y into this minus y into sin xy, so will be 0. Sin xy into this one y, so that will be y sin y to the right hand side. So this will be y sin y. So dy by dx equal to y sin y, y sin y upon twice sin y cos y minus x sin x into y. So twice sin y cos y means I can write dy by dx equal to y sin y upon 2 sin y cos y means sin 2y, that is sin 2y minus x sin xy, x sin x into y. So this is derivative. Now take next one, that is 8. Question number 8 is sin square x plus cos square y, that is equals to 1. So differentiating with respect to x. So sin square x, so sin square x, just we have seen sin square x, so derivative of sin square x is twice sin x into derivative of sin x, that is cos x, plus cos square y whole square, so derivative of twice cos y into derivative of cos y is minus sin y, since it is the term of y, into dy by dx equal to 0. Derivative of 1 is 0. So twice sin x cos x, this is minus twice sin y cos y cos y dy by dx equal to 0. Okay, so I am writing this twice sin x cos x equal to twice sin y cos y dy by dx. Okay, so this is 2 sin x cos x means sin 2x equal to, this is sin 2y dy by dx. Therefore dy by dx equal to sin 2x upon sin 2y. Okay students, in this way you find the derivative of the implicit functions for other examples.